Hey everyone! Today we're talking about Mercury, a planet that's full of surprises. But before we get started, be sure to subscribe to the channel and also like this video. It would mean a lot to us. It's the smallest planet in our solar system, just a bit bigger than our moon. And it's the closest planet to the sun. Now, being that close to the sun makes Mercury a real scorcher. Imagine this. During the day, the temperature on Mercury can reach a sizzling 800 degrees Fahrenheit. That's hot enough to melt some metals. But here's the crazy part. At night, Mercury gets incredibly cold. Since it doesn't have much of an atmosphere to hold the heat, the temperature plummets to a freezing minus 290 degrees Fahrenheit. That's a crazy temperature swing. This crazy difference between day and night temperatures is the biggest in the entire solar system. Over the next few minutes, we'll dive deep into what makes Mercury so extreme and uncover some of its secrets. Stay tuned. Let's talk about why Mercury is so incredibly hot during the day. You see, the sun is like a giant campfire, and Mercury is practically sitting right next to it. Because it's the closest planet to the sun, Mercury gets blasted with about 7 times more solar energy than Earth. That's a lot of heat. And to make matters worse, Mercury doesn't have a thick atmosphere like Earth does to spread out the heat, so all that solar energy just bakes the surface, making it unbearably hot. But here's the catch. That same closeness to the sun is also why Mercury gets so cold at night. Without a thick atmosphere to act like a blanket and trap the heat, the surface of Mercury loses heat incredibly quickly as soon as the sun sets. And to top it off, Mercury spins really slowly, so the days and nights are super long, giving the planet plenty of time to heat up to the max and then cool down to the extreme. Now, let's talk about Mercury's atmosphere, or should I say, lack of one. See, Earth has this nice, thick atmosphere that acts like a blanket, keeping the temperature just right. Mercury, on the other hand, has a super thin atmosphere called an exosphere. It's so thin, it's practically a vacuum. This means there's nothing to trap the heat from the sun. So while it gets super hot during the day, all that heat escapes into space at night, making it freezing cold. But that's not all. The lack of a proper atmosphere also means Mercury is constantly being hit by stuff from space, like solar wind and micrometeoroids. Imagine tiny little space rocks constantly bombarding the surface. It's a pretty harsh environment. Let's take a closer look at Mercury's surface. It's covered in craters, kind of like our moon. These craters were formed over billions of years from being hit by asteroids and other space debris. One of the biggest craters is called the Caloris Planitia, and it's massive. But here's the surprising part. Even though Mercury is so close to the sun, scientists have found ice on its surface. Now you might be wondering how ice can exist in such a hot place. Well, this ice is hiding in deep craters at Mercury's poles where sunlight never reaches. It's so cold and dark in these craters that the ice has been able to survive for billions of years. The discovery of ice on Mercury is a big deal because it tells us that even in the most extreme environments, we might find surprises like the ingredients for life. Even though Mercury is a tough place to visit, we've sent spacecraft there to learn more about it. One of the first was NASA's Mariner 10, which flew past Mercury back in the 1970s. Then, in 2011, NASA's Messenger spacecraft actually orbited Mercury for 4 years, taking amazing pictures and collecting valuable data. Thanks to Messenger, we now know so much more about Mercury's surface, what it's made of, and even its magnetic field. And guess what? There's another mission on its way to Mercury right now. It's called Bepi-Colombo, and it's a joint mission between Europe and Japan. Bepi-Colombo will study Mercury in even greater detail, helping us unlock even more of its secrets. It's amazing to think that we're still exploring and learning about our solar system, even the most extreme parts of it.